Hey guys, welcome to Code Decode. In this video, we are going to look into some Java 23 new features. So recently on 17 September 2024 this year, we have JDK 23 with us with the general availability. Let's click on this link and let's see how JDK 23 new features look like. Also, the phase for this JDK 23 has been started from June 2024 with ramp down phase 1, phase 2, release candidate 1 and the final release candidate with the general availability. It is now available in September 2024 with us. I've already covered what are release candidates and all these things in the previous video. Now quickly going with the new features that are the part of JDK 23 are the primitive types, the class file API, Markdown APIs, vectors, stream gatherers, deprecated memory, ZGC, module imports, implicit declarations, structured concurrency, scope value and flexible constructors. If you can view that there are two things to note down when we are reading the documentation from JDK. What are these preview, second preview, what is this incubator and what are these numbers? So first we will see what are these preview. Every feature is either implemented or is in some kind of preview or in incubator phase. So let's first understand before digging deeper into the new features, what is this first preview, second preview and third preview for us. So in the context of Java features, preview refers to the feature that are introduced in the version of Java but are not yet finalized. It is basically work in progress 1, work in progress 2, work in progress 3. Basically what happens is they ask Java developers like us to use these features during coding and see if it is actually following out the good practices and the design patterns in Java. Is it really important? Does it really make a change in our life during coding? And if yes, we give good feedbacks and it actually creates an impact in the JDK, then yes, they are taken from first preview to second preview to third preview and even more if it is more required, and at the end it is finalized and released as a feature. For example, this Markdown documentation comments are released as a feature. This memory access methods of unsafe removal is deprecated and it is final in this particular feature, JDK 23. Similarly, the generation mode of default is also finalized, but rest of all the features are in preview stage, but you will be able to see most of them in upcoming JDKs. But for this particular JDK 23, you must understand what these features are and why is it really important and what changes it affects as a developer. So let's get started. So as discussed, first preview is the initial introduction, second preview is the refinement based on the feedback we as a developer give during the first preview. The third preview is this feature is typically more stable and closer to the final form, but it is still subjected to change. So each preview is designed to encourage community of us as a developers to ensure and align with the Java overall performance and the design principles. And if they do, they are finalized. So hopefully in the third preview, like the concurrency, the scope values, we will be able to see in JDK 24 or 25. Here, let's quickly see what are these numbers here. These numbers are the JEPs. What is JEP? That is JDK enhancement proposal. So when you work in your day-to-day life, what comes in your sprint is the enhancement. Out of those enhancement, we create the stories and assign to us. Similarly, it happens in the JDK team also. What they do is they create the JDK enhancement proposals and they number it as 455, 466, 467 and so on. That's the unique identifier for each and every enhancements they do in the JDKs. Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used Cloud to deploy this application and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing, And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka Server and all those microservices counterparts. Now this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. Now going forward, let's see what are these enhancements all about. So first is a primitive type instance of and switch preview. Now let me quickly give you an example how pattern matching was done in Java. So I'll give you each and every feature is how it was, how it is now, and how it makes our life easy. And the code snippet also, so that you understand each feature and you will be able to answer them in interviews, because they can be trickier questions on such features. So pattern matching was available in Java using instance of method, which allows you to check if object is of certain type and then cast it directly in one step. But this was not available with primitives. Too much of theory, let's understand with an example. So initially we had an object. So we see, is object an instance of an integer or an animal or a class, any custom class. So instance of is a way to pattern match your object. So is the object of type this? Is it matching this particular pattern? Not just checks it, but also typecast it. So object, if it is an instance, directly print the number. So for JDK 23 code creation, you have to create a new project. I'll give you an example in IntelliJ how you can create a project with Java 23. With Java 23, I do not have anything in my system right now, but I'm going to install it from IntelliJ itself. So I'm going to name it as JDK23 demo is my project name. It is in my downloads folder. I'm going to use Java. It's detecting. I don't want to detect because I have only 11 and 17. I want to download a JDK. So if you can see, as you click on that pop-up, you can see the version is 23 and open JDK 23. That is the recent version that JDK has launched for you. So I'm going to use the open JDK for this, and it is going to be stored in my .gdks folder. I'm going to download it. It's getting downloaded and I'm going to create. So if you can see here, I have my main class created with hello world. Now here, I'm going to copy this code and I'm going to paste it here. So this is where I have an object. I am here checking whether it is a type of integer or not, and I am also typecasting it to an integer and printing it. So on running this, you would be able to see the object is pattern matched with integer and then it is printed here. But this does not work with primitives, it only works with the wrapper. So if I write int here, it will give me an exception saying primitive patterns are a preview feature and are disabled by default. Use -- enable preview to enable the preview patterns. So pattern matching is done with the primitive type. Now num is the primitive int, no boxing involved. But right now you'll face an exception like this. Primitive patterns are the preview feature and disabled by default. The reason for this is, I have shown you this is in preview. So the features that are in preview are not allowed until and unless you have enabled the preview for your compilation and debug. If you want me to tell you how to do that and how to enable the preview, let me know in the comment section. In the next video, I'll do that also for you. But right now, I'll quickly run these code snippets and show you how the preview features are not disabled. Right now disabled, but will be available to you in the upcoming JDKs. The second new feature is the class file APIs, which is in the second preview. Basically, it would have been already introduced with JDK 22, but in 23, it is in second preview. So the class file API was proposed as a preview with JEP 457 in JDK 22. Now this is in second preview with some refinements that are based upon some experience and feedback given by us developers. So previously, the class file format is very important in Java. So you remember that all the .java files are compiled to .class files. But there was no standard API for analyzing these .class files. So developers either use the external tools to decompile these .class files and see the source codes like ASM and BCEL. But now with JDK 23 and JEP 466, that is an enhancement for JDK 23, we have the second preview available with some more features available to this standard API, which simplifies the manipulations of .class file. Now, I am going to copy this code I'm going to paste it here and let's understand this code with an example. So this class file is now a part of Java Lang class file. If I try to run this, you will see that the class file is a preview API and is disabled by default. And that is the reason we are not able to use this class file for the package Java Lang class file. Here what I'm trying to do is to load the .class file, read it and do some access on the constant pools of the methods, but we are not able to do this with JDK 23 even though it is in place. The reason being it is in preview state. Now with JEP, this changes are if you enable the preview, you will be able to use and access them in your code also. The third is the Markdown documentation comments. This is a full proof feature implemented in JDK 23. This is not a preview of any of the previous JDKs or enhancements. Here we have enabled the Java doc documentation comments to be written in Markdown language rather than solely a mixture of HTTP and Java docs. Too much of theory, let's see it with a code base first. So if you can see here, this is the code base. How did we write the documentation? We just did this /** and enter. This is the complete Java doc that comes up for us in the IDEs, right? Now this was just the combination of HTML and some tags. Here it is a complete markdown which is starting with /// 3/ basically. So it made things very easy for us because now it is easy to read, easy to write and easy to transform into an HTML. Initially when this was introduced in 1995, HTML was the very first choice for the developers, but that was long back in 1995. Nowadays, HTML is no more a standardized way for documentation. So that is the reason we have introduced markdowns where the simple document is created which is easy to read, write and transform. Now if you want to see the key differences, first of all, it doesn't start with this **/*. It rather starts with --, //, 3/ basically. The P tag is no more required. A blank line indicates a new paragraph like this here. The UL and LI tags are now replaced by dash here. You can see this is dash. The EM tag is now replaced with quotes like this. The tilde that we use here. The @link is now replaced with the markdown reference of this. In essentially, @IMPL spec return and C remains the same here also. So these are the special changes that are done to the documentation that we do in Java. So if you are going to move to JDK 23, remember you have to make changes to your Java docs also. Now the fourth very important change that came into picture is the vector API. Now this is an API and it is an incubator form. Previews are for the features. Incubators are for the APIs. So let's first see the difference between incubators and previews. These are the APIs while these are the features. The scope of incubators are the new APIs or libraries. The previews are the enhancements scoped. Maturity for the incubators are early staged while previews are the changes which are close to final. The API changes can even go to 8, 9, 10 or multiple releases, while for the previews it's typically limited 1, 2 or 3 releases. So that's why mostly this third previews are usually going to be available to JDK 24 next. So that's the main difference between the APIs and the features we have. Now what is this vector API feature? So initially in Java, before Java 23, we had limited scope support for vector computations which are very essential for performance critical applications such as machine learning and numerological computing. But now vector APIs, which is still an incubator but might be available very soon for the upcoming JDKs, will provide a way to perform vector computations that supports the SIMDs, that is single instruction multiple data, which improves the performance in multiple ways. So if you can see here with the int vector, we get 2 results, we add them and we make it into the array. Basically these are the ways of doing the vector API computations. Now if I try to copy this and paste it here, I can get this vector. If you can see what is the package name for this API, that is JDK incubator vector. That means this particular int vector is still in an incubator zone. It is not yet finalized. So if you try to run it, you will be able to see the exception again, that JDK incubator is not visible because it is not a part of module graph. So it's still an incubator, not yet in use by the normal developers. If you want to use it, go to the preview mode. Now stream gatherers, this is the 5th very nice feature that is added, which is in second preview right now. This is very much similar to streams.collect method. So what we do is we create a stream with the of or anyways, whatever the stream object is created, we do dot collect and collectors dot toList. Now they have gatherer in place. What does this gatherer do? Before, working with stream was more structured way, was not possible, but could be verbose or limited in terms of grouping or gathering. But now with this enhancement, the gather operation allows the better control and optimization when collecting the data from streams. Now what is the difference? The gatherer is expected to provide more optimized results and better control over stream, and particularly in parallel stream. When it comes to collect, it has a very bad performance with the parallel streams. But now gather is going to have a very good optimization in the particular applications which are performance critical applications. There, rather than using collect, you can use gather and use it in parallel streams for the best results for operations that you do in streams. So this is just an enhancement done for increasing your performance of your application, so that if you use parallel streams for the good response, you will not have a bottleneck because of collect method. So collect is still widely used general purpose operation that works for everyday use cases, but not for the performance tuning or specializations for the certain critical situations. The sixth change that is done is deprecation of memory access methods like unsafe for removal. So before this enhancement, this sun-misc unsafe allowed the direct memory access and manipulation widely by developers in the low-level operations, but it was very dangerous. So you remember JDK says that you are not intended to change the memory pointers like you are able to do in C++. JDK is quite more abstracted when it comes to pointers, but still there was a direct memory manipulation allowed, not with the pointers, but one of the package called as sun-misc unsafe. Using this, you would be able to change the memory directly. And this was a very dangerous threat, because earlier what we can do was, we can use the unsafe class, get the field, set its visibility to true. Even though it is private, you would be able to make it public now. You can have the memory access to it, put an integer to it, and do the value storing into that memory, and then free the memory. Now can you see if what will happen if you forgot to free the memory? Memory leak will happen, because this memory is not going to be garbage collected, because you have manipulated this memory by your own, not with any memory management done by Java for you. So garbage collector will not know about this memory area because you have manipulated it with your code base. So this gives you a very bad, dangerous situation of memory leaks. So here you can have the memory leaks, you can have the segmentation fault, you can have multiple checks getting unsaved and out, like for example, out of bound access, buffer overflows and all such situations. So this is not basically recommended. Also, you might have portability issues. It might work in some JVMs. Some may not be able to run it because that is JVM specific. So this will cause you a problem. So instead of using the unsafe, which is a library from the sun-misc unsafe, you can rather directly use the method handler lookup for the where handle. So the safe alternative for this unsafe is the where handle, which is where you can access the memory. So now how the code will look like is, you can have an inner class. Now you want to access this class. So you will use a where handle to look up to the meth field and then change this field using the value of it. So this is much better way for handling your memory addresses. The seventh enhancement that was done was the generational mode by default for ZGC. Now ZGC is the Z garbage collector, which was non-generational. When I was covering the garbage collection, I have told you that most of the GC1, GC2s, GCs are generational in nature. What does that mean? That means every object is termed as young or old in terms of their age. And there is a concept called as young dies early. Basically, it's said that mostly those variables which are recently created might be available for the garbage collection very soon. So that's die young theory of generational garbage collector, which helps the garbage collector to quickly garbage collect those memory areas which are recently created in the local scope and as completely removed whenever the local scope completes. So that's what was generational all about. But the ZGC was non-generational, means all the objects are treated equally, though it is created early, though it is created since a long duration of time, they were considered equal, even though most objects are short-lived. So now what change they have done is they made the ZGC as by default the generational. That means the ZGC will also consider object as young objects or the old objects. The 8th enhancement done was module import declarations. This is in preview. Now in the traditional approach, how it was earlier. So whenever I have some dependency on a library, for example in the POM you add the dependencies, right? So what you do, you go there and you add the security dependency. With that, hundreds of class files are added to your code base, which increases the size of your code, which is so bad, right? Because now the entire library is added to your code base, which might not be needed. I just want one class out of it. So traditionally, there is an approach to make the entire module dependent on another, even though we just want to use a small proportion of that module. So in that case, now with JEP 476, you will be able to import modules locally without to declare them globally. Basically, too much of theory. You will have more control over the module dependency and you can import only those that is required and remove others. So the key benefit of this is the cleaner declaration, greater flexibility, and you have more modularity, less coupling, and it actually reduces the size of your code base also. Now the 9th one is implicit declared classes and instance main method. This is in 3rd preview. I would say this is the most important change that was done in JDKs till date. And this actually completely changes the way how we code the main methods. So if you can see here, whenever I have to write a class, what I do? You create a class, you write public static void main. This is the first thing that we ever do to start our application when we code in Java. The JDK people changed this. What they did is, no more static required. Why is this redundant static variable required? We say that this is required because JVM, rather than creating an object of main class, it can directly call the main method because it was static. Now the JDK people says, not needed. It's a small task that the JVM has to do. What it has to do is create an instance of main and then call the main method. And also remove these arguments. Many of the times you don't use these arguments. So these are the redundant command line arguments you give. Nowadays everything happens in the IDEs. You rarely pass any arguments for the main method. And this is the biggest change I would say that the JDK people could do for us developers who are working in Java for a long time. So in Java, the entry point was for the standalone application was a static method called as main, like this public static void main, where the main has to be static. You always have to declare a class in the particular scope, and every standalone application start with public static void main. Now forget about public static void main. It's no more going to be static for you now. Now the main methods are no longer static. They are instance methods now. And essentially Java now has to create an instance of this class, and this aligns actually more with the object-oriented principle of nature of Java also. In Java, everything is object. So why not JVM create an object of your main class? Can it not do it, right? It can. Internally, it can easily do it. So since this is now an instant method, now you don't have to think about the non-static variables also. Initially, since the main method was static, you have to create all the methods and variables also static if you want to use them in your main method. Now that restriction is also removed. So what good thing that has been done is now you don't have to have things static just because your main method want to access it. You don't have to create a static method. You can create a normal instance method. You don't have to pass any arguments because it is redundant. Most of the time we developers do not pass any arguments essentially. So that is the reason now we have a main method just simple like this. Public static void main is now completely removed. You have a public class app, you have public void main, and this is an instance method. This is no longer static. When JVM starts, it creates an instance of your main class which is having a main method. It will search for the void main signature and calls this method internally, and hence no need for boilerplate codes, no need for any argument passing. If you can remember, essentially there is no argument passed to this main method, and this is the exact signature that JVM looks for in or any of the class for the main methods. Also, there is one very big change done with this 477, that is the new enhancement for JDK 23. That is where we can implicitly declare the class. Too much of theory, let's see. Instead of writing public class myapp and only one method main with a system.out.println, why is this class declaration necessary? Only one method is important, that is main method, and that's all that I have to do in a very small application. So you can implicitly declare a class. That means you can remove this class signature. You can just directly create a class, new file, Java file, and that's it. You can name it anything and you can ignore this line completely, the public class and the name of it, because it is explicit that only one method is there. So you can implicitly declare the class like this. That's it. And by this, you have many benefits. Firstly, you have the simplicity for small applications. If your main method has to do just one task, internally call another API or service, one single line task, then why to declare a class? You can have implicit declarations. Instance methods are now much more flexible. You don't have to use the static members only because of the static constraint given by the static main methods. It is much more easier to use. It is more likely towards the object-oriented programming paradigm, because now JVM also have to create an object of your main class. So with this, there is one important question that you can ask me, or I am expecting these questions in the comments, that if the arguments are now removed, how can we pass arguments? So now a way to do that is through informant variables. Now concurrency, when it comes to your mind, concurrency, what you think is creating two threads using executor framework. So before, we used to handle concurrency manually by creating the thread t equals to new thread or with the executor service like this. But now this was much more structured by managing multiple tasks in a simplified tight scope. Basically, the transactions are now handled here very much cleanly and efficiently, and also ensures that the resources are automatically cleaned up after the things are done. So it ensures that either all the tasks are done completely together or failed together. So basically a transaction is mentioned. So what they do is, there is a try catch here. So here we have future 1, future 2, and it has the join. Basically it will wait for both the features to come. The good thing is that with try with resources, you can see this is the try start and this is the end block for this try. Basically it's try with resources. It will make sure that even if you forgot to close your futures, it will still be cleaned up. So this code now will make sure that all your futures complete together. Also it is closed and cleaned up because of try with resources. So with this structured concurrency, managing multiple tasks is simplified as the tasks are tied to a scope. This is the scope with which all these tasks are tied up, which ensures that it is cleaned up and is handled in a very efficient and coordinated way. And also it will ensure that by the end of this line, if both the futures are not able to complete successfully, both the futures will be rolled back. Either, or if they are done successfully, both of them will be committed. The 11th one is a scoped value. So when it comes to your mind of passing a value from one thread to another, basically one of my thread is working and it has some computation of a value or a variable that has to be passed to the another thread. How did you do that? You have done that using thread local, right? Before, how you used to do it? We use thread local to share data across threads, which could lead to memory leaks and complexities if not done carefully. So how did we do it? We created a thread local in one of the main thread. So this is run by the main method. So this is the main thread running it. So it sets the name as John Doe. Now a new thread is created and it is going to access the thread local.name from here. So one thread, the main thread, is giving the John Doe value to the new thread created with the name of thread. So this is how you pass the name John Doe from the main thread to the child thread. But this is very much risky because it gives you the risk of memory leaks and complexity interactions. Even if you forgot to do the cleanup or the removal, the cleanup will give you the more of the memory leak issues. Now the better approach is a scoped value. So rather than using the thread local like this here, you rather use a scoped value like this here. Now scope value defines you a way or a process to significantly reduce the chances of memory leaks. And hence, whatever you pass to the scoped value as John Doe, you can access it in your child thread also. So it is very similar to thread local, but is designed for the structured concurrency. It was, if the value is set with the try with resources, you will not be able to have the memory leaks also. Also automatic cleanup will be done, which was the manual work with the thread local. The last and very important enhancement, which will be in the second preview for JDK 23, is the Java constructors used to be very strict. If you remember, if I'm writing a constructor, that has to be the first rule, that the this and super has to be the first line. Remember, when we were in the very initial phase of Java learning, we knew that if you are writing a constructor, the first line has to be this or super. So much complicated, so much strict rules, too much to remember. Now this JEP 482, which is my favorite, this is where the rules are now less stricter than initial. This super can be anywhere later in the constructor also, and before that we can have some validations also and some line of code also. So before, Java had constructor has a strict rules, now it is more flexible. Before, we used to explicitly write the super or this call as the first statement. Now it is not explicitly needed, it can be at the end also. The order of execution, that super and this has to be the first to be executed, which is not the case now. Error handling, before we had very limited error handling, right? Because after super, we just do the throws. Now, because super has to be the first line. Now, with the try, catch, if, else and everything can be called before super also. And that is why we say that now constructors are much more flexible than the previous ways. So that was all about the changes that was done with the JDK 23. Most of these third preview we will be able to see with the JDK 24 soon. If you want to know more about the features for the earlier Java versions like JDK 21, 22 and so on, let me know in the comment section. I'll create videos on them too. And these are very much nowadays a hot topic during interviews. So remember to thoroughly learn about these features and also be prepared for the tricky questions which can be done around this. For example, I have been explicitly asked that if now it is a main method, if I have two main methods, how will the JVM know which has to be called? The essential answer to that is the signature is what makes it a main method now. He didn't explicitly told me that the static is now removed. He just gave me a thing that now I'm using Java 23 and these are two methods. Which do you think the JVM will call? Just because I know that with Java 23, the static keyword will now in the preview mode will be removed. But I also gave an answer that this isn't still in preview mode. So if you try to still use it in the Java 23, you will not be able to because it is in preview mode. For this, you have to enable with -- enable preview. So if you want more such tricky questions for Java old JDKs like JDK 11, JDK 21, 22 and so on, let me know in the comment section. I'll create another video for them also. Thank you.